Get ready for two upcoming solar eclipses. An annular eclipse next month will cross North, Central, and South America. A total eclipse will cross North America in April 2024. We're talking to an SwRI Solar Astrophysicist and eclipse expert about what to expect and how to prepare for these extraordinary celestial events. That's next on this episode of Technology Today.
We live with technology, science, engineering, and the results of innovative research every day. Now, let's understand it better. You're listening to the Technology Today podcast, presented by Southwest Research Institute. From deep sea to deep space, we develop solutions to benefit humankind. Transcript and photos for this episode and all episodes are available at podcast.swri.org. Share the podcast and hit that subscribe button on your favorite podcast platform.
Hello and welcome to Technology Today. I'm Lisa Benya. Two upcoming solar eclipses will be visible in the United States. Now's the time to make plans on where and how you'll view these can't-miss celestial events. An annular eclipse is happening on October 14th, 2023. Then we'll see a total eclipse on April 8th, 2024. SwRI Solar Astrophysicist and Principal Investigator of the NSF and NASA-funded Citizen-Kate 2024 mission and the NASA WB-57 JETS airborne mission, Dr. Amir Caspi, joins us now from SwRI Solar System Science and Exploration Headquarters in Boulder, Colorado. He's here to share his expert eclipse insight and to talk about what you need to know ahead of these sure-to-be spectacular events. Thanks for joining us, Amir.
Thanks very much, Lisa. I'm happy to be here.
All right, so we'll talk more about your team's eclipse projects coming up. We're excited to hear all about that. But let's start with Eclipses 101, the basics. Please explain this event. What is happening during an eclipse?
Well, Lisa, we live in a really special time. We have a big moon and we have the sun, and it turns out that even though the moon is a lot smaller than the sun, when you look at them in the sky, they look about the same size because the moon is smaller, but it's a lot closer to us. And as the moon orbits the Earth, sometimes it will actually cross in front of the sun. And when it does that, in a particular configuration, it can cast a shadow on the Earth. When it does that, we have an eclipse.
All right, awe-inspiring and spectacular for all of us to see here on the ground. How many eclipses have you seen?
It turns out that even though I have run some experiments for total solar eclipses, I have only seen one in Australia of this year, 2023, and that was only for a few seconds.
So you've seen one total eclipse live in person.
That's right.
Have you seen other kinds of eclipses in person?
Yes, so of course, just like many people, I've seen total lunar eclipses quite a number of times. But I've also seen a number of partial solar eclipses and one annular solar eclipse.
All right, so your eclipse count is going up as we speak.
That's right. I'm very much looking forward to 2024. That will be somewhere between 3.5 and 4.5 minutes of totality over the United States. It's going to be a spectacular experience.
Okay, so that total eclipse is the big one coming up. But before that, the U.S. will experience an annular eclipse on October 14th, 2023. And as we just said, that total eclipse will be April 8th, 2024. So what is the difference here between the annular and the total eclipses?
So they both work very much the same way, but the moon isn't always the same distance away from the Earth. Sometimes it's a little bit farther away, sometimes it's a little bit closer. And the Earth is also sometimes closer and farther away to the sun. So the size of the sun and the moon in the sky changes just a little bit all the time. Sometimes the moon is not quite as big as the sun in the sky. And when that happens, the moon doesn't fully cover the disk of the sun, and you can see this bright ring of sunlight around the moon. That's an annular eclipse. When the moon is a little bit closer or the sun is a little bit farther away, then they look somewhat different sizes. The moon looks a little bit bigger. It's big enough to cover the sun in the sky. That's when you get a total eclipse.
So many people are excited, making plans to see these events. And in preparation for these upcoming eclipses, how can we safely view them? That's a huge point that Everyone needs to understand there's a safe way to do this. So, what are your tips?
That's right. This is a very important question, and there's actually quite a lot of misunderstanding about how to safely observe an eclipse that always goes around when eclipses come about. It is safe to look at the sun only through special solar viewing glasses. You can find these sometimes at telescope stores. You can probably find them online. These are glasses that have a sort of silvery lens on them. That is a special filter that cuts down the light from the sun by about 100,000 times. And it is safe to look at the sun actually at any time through that kind of filter. You don't want to ever look at the sun with your naked eye except during the totality of a total solar eclipse. The reason that that is safe is because when the moon is covering the full disk of the sun, what you see is the solar corona, its outermost atmosphere. And that is only about as bright as the full moon. It's safe to look at the full moon with your naked eye. It's safe to look at the solar corona with your naked eye when the disk of the sun is covered up by the moon. Any time that the disk of the sun is not covered up by the moon, which means during a partial eclipse, during an annular eclipse, or just regular every day, you only look at the sun through those special filters. There are other ways that you can also safely observe partial and annular eclipses, and that's using things like projection. You can make a little pinhole projector by taking a sheet of paper and punching a small hole in it, and the sun will project through it and cast a shadow on the ground that you can use to track the eclipse. You can also see those same kinds of images coming through natural pinholes, like the gaps between the leaves of trees, or you can take a pasta colander and cast your own pinhole images. And there are other specialized solar projection equipment that you can also buy. If you search for safe ways to view an eclipse online, you'll find all sorts of answers.
A lot of great options there, whether you want to do a homemade projector or look at your other projection options. However, if you want those special glasses, if you haven't already done so, now's the time to order your eclipse glasses. But safe eclipse glasses must comply with rigorous safety standards. What should we be looking for when choosing eclipse eyewear?
This is a great question. This was actually a problem back in 2017 when there were some lower quality glasses released that had to be recalled. What you want to start with is look for a reputable company that has been vetted by major government agencies. Both NASA and the National Science Foundation release information on safe eclipse viewing glasses. They're actually, I hesitate to call them eclipse viewing glasses because during totality, you don't want those glasses on. Let's call them solar viewing glasses. There is certification that those glasses have to go through. Those are either ISO standards or ANSI standards, and you want to look for that certification number printed on the back of the glasses, along with all of the warnings to not look at the sun without those glasses.
All right. And eclipse glasses, or solar glasses, as you call them, are not regular sunglasses. We want to stress that no matter how dark, regular glasses are not safe for viewing the sun. So safe solar viewers are thousands of times darker and must comply with the ISO or ANSI standards that you mentioned. So do you have other safety tips to share?
If you are using eclipse viewing glasses or solar viewing glasses, you want to make sure that the film doesn't have any holes or other gaps in it. You want to make sure you inspect it carefully before you look at the sun. And the safest way to put them on is don't face the sun when you put them on. Put them on facing away from the sun and then turn towards the sun. That means that you don't have any chance to accidentally expose your eyes to the unfiltered sun. And by the way, the reason this is dangerous, during a normal day when the sun is super bright, you're not going to hurt yourself if you glance at the sun by accident because your pupils are so small, you don't get a lot of light and it hurts to look at the sun. You look away very quickly. when it's partial eclipse, the sun is actually a lot dimmer, and you don't notice this because your pupils in your eyes get bigger to make it look like it's just as bright. But because of that, you're letting so much more sunlight into your eyes, you don't notice that it's bright and damaging your eyes. So you always want to be very careful. Don't look at the partial eclipse or the annular eclipse with your naked eye. Look away from it, put on those glasses, then look towards it. Again, the only time that it's safe to look at the sun without that special protection is during totality of the total solar eclipse.
All right. And the annular eclipse is what's coming up in October. So, again, to repeat what you just said, you do not want to look at the sun at any point during that annular eclipse coming up in October. Now, the total eclipse happening in April. Let's discuss that moment of totality again. When can you look at the sun? When it's completely covered by the moon?
That's right. That's right. And in fact, you'll know when this happens. As the moon covers more and more of the sun, the light starts to get dim, it starts to get flat, and it'll look very, very strange. This all happens noticeably within the last minute or two right before the eclipse. It'll look like it's becoming almost twilight, and then very quickly it gets dark. As soon as the moon fully covers the sun, you'll notice, then it's safe to look at the sun with your naked eye. As totality is ending, something we call third contact, if you ever hear that phrase, you'll start to see what's called the diamond ring. That's when the moon is just moving away from covering the sun, and the sun is sort of peeking out through the valleys on the moon. As soon as you see the diamond ring, look away from the sun, put on your safety filters, and then you can look again. One other thing is you want to be careful not to look at the partial, annular, or unobstructed sun through anything that is magnifying the sun, like a telescope, a camera lens, or binoculars, or similar types of equipment. The only way that that's safe to do is if you have a special solar filter that goes on the front of that equipment. Make sure you talk to your camera dealer, your telescope expert, or somebody else to make sure you're using the right filters. Don't wear solar glasses and look through any sort of magnifying device, because you can seriously injure yourself that way. The filter always has to go on the front of whatever it is that you're looking at.
Okay, so great information again to keep us safe during these upcoming events. So where is the best place to view these eclipses? So let's start with the annular in October, because that has a certain path. The total eclipse will have a different path. So where do you think is the best place to view the annular eclipse in October?
Well, if you want to see the annular eclipse in all of its glory, where the moon goes right in front of the sun and you get that ring of fire around it, you want to be along the center path of that annular eclipse. And that starts in Oregon, goes through the various mountain states, including clipping a corner of southwest Colorado, down through New Mexico and into Texas. You can, of course, find maps of this online, and if you can get yourself to one of the center lines there, that's the best place to watch. Now, of course, one of the problems with looking at the sun from the ground is there are sometimes clouds in the way, and this is the bane of every eclipse chaser ever. So you want to find a place that is likely to have good weather and not too many clouds. If you can be on a mountaintop, that's the best place. If you can't be on a mountaintop, check your weather forecast. There are also maps that can predict what is the likelihood of seeing clouds. You're probably going to be best off somewhere near the south or in a very dry climate.
So let's talk about the total eclipse. What is the path and where's the best place to get a good view of it?
So the total solar eclipse in April, it makes landfall in North America on the west coast of Mexico over a city called Mazatlan. In the United States, it crosses into the U.S. in a town in Texas called Eagle Pass. Then it goes up through San Antonio, Austin, Dallas, up into Little Rock, Arkansas, Oklahoma, into the Midwest over southern Illinois, including Carbondale, and then up into upstate New York, Rochester and Buffalo, Niagara Falls, and then into New England, Vermont, New Hampshire, and Maine. Probably the best place that will have the least amount of cloud coverage is in Texas. Of course, there is a lot of Texas to observe the eclipse
Right.
from. It's a big state. So if you can make it to Texas, that is probably your best bet in the United States. If you can go to Mexico, the weather is likely to be even better. But that being said, clouds, of course, are not a guarantee no matter what. There is a chance of seeing the eclipse everywhere, and if you can even drive a little bit north or south, east or west, you might even be able to escape the clouds. Sometimes you just get unlucky and there's a cloud right in one place in the sky, and if you move a little bit, you can then escape it and see the eclipse. So the southern United States, particularly Texas, will probably be your best bet, but if you can't make it there, you should still try to watch it. It will be a spectacular phenomenon.
So as we mentioned at the top, you are in Boulder, Colorado, but SwRI headquarters is right here in San Antonio, Texas. So we are excited about the paths of those two eclipses. We're kind of like at a cross point here in San Antonio. Maybe the first eclipse will probably get a better view of the second, maybe a little on the outskirts of San Antonio. But yeah, we're in a great location. So we're excited to have these two eclipses right in our own backyard.
Yeah, the Southwest Research Institute campus in San Antonio actually gets more than a minute of totality, even without leaving the grounds of the campus.
You have been studying eclipses, you research eclipses. From a scientific perspective, what can we learn from the eclipses?
We can learn an amazing amount from eclipses. Eclipses are a unique and rare opportunity to study the sun's outermost atmosphere, the solar corona, in ways that we really can't do at any other time and in any other way. Normally, the corona is too dim to see from the ground, particularly in visible wavelengths, the kind of light that we see with our eyes, because the sun's disk is too bright. It just completely covers that up. And of course, the sky is too bright because the sun is shining. If only we could observe the corona at night, then we could get the best view. And it turns out that's exactly what happens during an eclipse. When the moon covers up that disk of the sun, it's almost like nighttime. The sky becomes so dark that you can actually see stars and you can see the solar corona with your naked eye. Now, we can see the solar corona from space with special instruments. We can even see it from the ground with special instruments called coronagraphs that are like an artificial eclipse. They put an occulting disk in front of the telescope to block out the sun. But they still have to look through the atmosphere, look through the bright sky, or up in space, the instruments have to be made relatively small, and there are issues that they have to contend with that means their observations can't be quite as good as we would love them to be. During an eclipse, we avoid all of that. We can look at the solar corona with cameras that are not ready for space and that can provide us with better observations than we can get from space. We can see the corona in much more detail and much closer to the surface of the sun than we could do either with a coronagraph or from space. And we can study phenomena that we otherwise could not see because we have so much more detail available to us.
All right, so I want to go back to 2017. You were principal investigator of the NASA WB-57 mission. Your team chased the August 21st, 2017 total eclipse in two high-altitude aircrafts. So what was that like? What type of data did you collect?
You know, that experiment was something that I will remember for the rest of my life. These aircraft fly at altitudes up to 65,000 feet, it's very high. Most passenger jets fly somewhere between 30 and 40,000 feet. And why is that important? Well, it turns out that if you can get above most of Earth's atmosphere and above most of the water vapor in Earth's atmosphere, you can actually look at the sun in wavelengths of light or colors of light that we cannot see from down on the ground. And for this particular experiment, we actually used a special camera that looked at the sun in infrared light. And the particular wavelengths of infrared light that we looked at, you cannot look at from the ground because the sky actually glows in those wavelengths. So if you can get above the atmosphere, you can see the sun. And it turns out that the solar corona has only been observed at those wavelengths of infrared a handful of times. And there's just a lot we don't know about what the corona looks like and how it behaves at those wavelengths. So that was a unique experience. One of the interesting things is those airplanes actually flew in formation. We flew them one after the other so that the eclipse shadow would pass over one aircraft, then the other, and they would both briefly be in shadow at the same time so that we could put together the data from both aircraft to get 7.5 minutes of totality, which is almost 3 times longer than you would get if you were standing on the ground. Those aircraft had to fly in formation 100 kilometers apart, but timed only a few seconds of precision. And they were able to hit those marks precisely the first time, no practice. It was a sight to behold.
And are you still going through that data? What have you pulled from it?
Yes, we are indeed still going through that data. It turns out there's so much interesting stuff there that we are still digging through it. In fact, we're going to be running this experiment again in 2024 with new instruments. And as part of the preparation for that, we're going back through the data from 2017. One of the interesting things that we saw was that there are 2 different types of structures in the solar corona that were both glowing in infrared light, almost with equal brightness. One of those structures is what's called a prominence. This is material that's basically coming from just above the solar surface, and it has temperatures of only about 10 or 20,000 degrees Celsius, or degrees Kelvin, as we like to think of it.
Only,
yes. Of course, it's much, much hotter than what we're used to, but
Yeah.
on the sun, that's
On the sun,
really
right.
cold, actually.
Yeah.
And those things are actually really interesting, by the way. During a total solar eclipse, you can see those with your naked eye. They will look like red loops above the surface of the moon's limb. And so we were seeing them in infrared light, but on the other side of the sun, we were seeing coronal emission from what's called an active region. This is the corona that's above a sunspot. And the temperature of the corona there is millions of degrees Celsius. It's incredibly hot. This is one of the big questions that we're trying to answer about the sun. Why does the corona get so much hotter than the surface of the sun? That's something unusual. It's something that doesn't really happen. It's kind of like if you were around a campfire and it got hotter as you walked away from it, which is something very weird. So one of the things that we're trying to study is why that happens, and the infrared light that we observe will hopefully help us to answer that question. In 2024, we're going to be using a new instrument that can give us more insight into that infrared emission from prominences and from active regions. They have temperatures that are more than 100 times different, and we'll hopefully be able to get to the bottom of why they are glowing in infrared and how.
All right. So your purpose for viewing the eclipse is much deeper than those of us on the ground who just want to see something cool. You are getting answers for us. That's really fascinating what your team is digging into. And as we mentioned at the top, it doesn't stop with that mission. You have a couple things going on. So you're working also on the Citizen Continental America Telescopic Eclipse Experiment, or CATE 2024, funded by NSF and NASA. So the team is now ready for 2024. Tell us more about your plans for the upcoming eclipse with this team.
So CATE 2024 is an interesting experiment. This is what we call a citizen science or community participant experiment. We're going to be doing professional science, but we're involving members of the community to help us acquire that data. So the moon's shadow over the Earth actually moves really fast during an eclipse. At its slowest, it is traveling about 1,500 kilometers per hour, or almost 1,000 miles an hour. And it gets faster from there. That's almost twice the speed of sound. And it is something that you can't keep up with in an airplane. And of course, if you're just one person on the ground, you only get to spend a few minutes in totality. It turns out the solar corona is dynamic. There are things happening there, not just on timescales of minutes, but on timescales of an hour or more. And we really want to be able to observe the solar corona for more than just a few minutes of totality. So if we can't chase the eclipse, we can make the eclipse chase us. And that's what Citizen CATE 2024 is all about. We're going to get about 35 teams of local community members who happen to live along the eclipse path, and we're going to provide them with special telescopes and cameras and training and help them follow procedures that will get scientific quality data. Everyone along the path is going to get the same equipment, the same training, and they're going to follow the same procedures. And then the eclipse shadow is going to pass over every one of those 35 stations in sequence from Texas all the way up to Maine. And that lets us then stitch together the observations from each one of those stations to make an hour-long movie of totality. We're going to be using special cameras that are sensitive to the polarization of light. Now, if you're not familiar with polarization, everybody, maybe not everybody, a lot of people actually wear special filters on their face. They're called polarized sunglasses. So light is like a wave. It waves in a particular direction, and polarized sunglasses cut down the light that's waving in directions you don't want. It turns out that the direction of that light wave is actually quite important for science. And if we can measure that angle of polarization, we can learn things about the sun that we can't learn in other ways. So we're using cameras that have special filters on them that are sensitive to that polarization of light from the corona. And we will be making those measurements from each one of our 35 stations.
Okay, and the CATE team actually traveled to Australia in April 2023. So, what did you learn there, and how did that experience prepare you for what's coming up in 2024?
Well, yes, we took members of the CATE community leadership. We have regional coordinators and lead trainers who are helping us to recruit and train the 35 teams of community participants. It turns out that if you're doing an eclipse experiment, practice is absolutely essential. The eclipse happens only once. It doesn't come again. And if you don't get it right the first time, you don't get another chance to do it again. So practice is really important. And because we have new people on these teams that may never have performed this kind of experiment before, we're using new equipment that we've never used before. It was really important to test it. And the total solar eclipse in Australia was a perfect opportunity to test the equipment, the procedures, and to get training for our community leaders so that they would be able to pass on that experience to the new teams who will be observing the 2024 eclipse. The most important thing that we learned is that the observing techniques worked, the equipment works. We learned how the camera performs and how the telescope performs, and that lets us make refinements to the equipment and to the training before the 2024 eclipse.
So you mentioned this was your one total eclipse that you've been able to see live in person. So what did that moment feel like? What did it look like?
You know, in some sense, it's almost indescribable. I am a solar scientist. I know what an eclipse is supposed to look like. I've seen pictures of them. I have seen the sun in many different ways, but actually seeing it with your eyes is something, it's really, really difficult to describe. The sky is dark, like twilight in the evening, but it's almost noontime. And then you look up to where the sun is supposed to be, and it's like there's a black hole there. It is surrounded by this crown of light that it looks kind of like what you think the solar corona might look like when you draw it as a kid, but
Mm.
this is something that you've just never ever seen outside of a total eclipse. And really the moon is so dark, it looks like a black hole in the middle of the sun. It is something that you really have to see for yourself. It is a transformative experience for many people.
I think transformative is a great word for this type of event. Huge opportunity to see a total eclipse. And again, that's coming up in April. For those of us who are not scientists, it's just going to be neat to see. So, would you suggest making a special trip just to see the eclipses that are coming up, or at least a total eclipse?
I would definitely recommend trying your hardest to see the total eclipse. If you live anywhere within an easy driving distance of somewhere you can see the total eclipse, it's something that I would absolutely recommend. For most people, seeing an eclipse is difficult because you usually have to travel to some very remote location. It can be very expensive, very time consuming. This eclipse is special because it crosses over so much highly populated and easy to access land in the United States and in Mexico and in Canada. If you can travel to see it, I really, really would strongly recommend it. You can get multiple minutes, 3.5 to 4.5 minutes of this transcendental, transformative
Yes.
experience. And if you can't travel to see it, if you don't have the time, if maybe it's just too expensive to go travel to see it, if you have to be at your job, you will be able to observe the eclipse on TV, online. I really recommend, even if you can't make it, to see it with your own eyes, to engage with the eclipse in some way on the day.
It's such a rare opportunity. And, for some, it's a once in a lifetime opportunity. We won't see the next total solar eclipse in the contiguous United States until August 2044. So you don't want to miss this opportunity.
That's right. I think if you can make it, you will not regret it.
Where will you be viewing the eclipses and how are you preparing?
I don't know exactly where I'll be yet. I am in charge of the Citizen Kate experiment for 2024. I'm in charge of the WB experiment for 2024, and I need to be in a place where we can do both of those. What we're hoping is that we can put the WB-57 mobile command center in the path of the eclipse. If that happens, then I'm probably going to be somewhere in Texas. I don't know exactly where, but it might be around the San Antonio area. It might be around the Dallas area. If we can manage to do that, we can run the WB-57 mission, which will be observing the eclipse as it makes landfall over Mazatlan, Mexico. And then just a few minutes later, the shadow of the eclipse will pass over the United States, over Texas. So we'll be able to run the airborne experiment and then run our ground community participant experiment and witness the eclipse ourselves all at the same time. It's likely that that's where I'll be, but we will have team members all around the country.
Okay, and you're talking about the total eclipse in April. Are you going to catch the annular eclipse in October?
Yes, we are actually. I probably won't see the annular eclipse in its full glory of annularity, so to speak, because as part of the Kate 2024 experiment, we're actually planning an outreach event. We're going to go up to Climax, Colorado, which is the site of the first coronagraph in the United States. It's basically where solar physics was born in the United States. And we're going to take one of our Kate 2024 observing stations and turn it into a homemade coronagraph to try and see the solar corona during the annular eclipse. We're doing this from Climax because how fitting is it to try and make a homemade coronagraph and see the corona from the very site of the first coronagraph in the United States?
Yeah, how amazing. Is that an open to the public event or?
No,
Okay, unfortunately not.
unfortunately not. That site is owned by a mining company, and we have to arrange for special access, which we have not yet secured. If we can't do it from there, we'll be somewhere nearby. But we will have one of our team members in Sandia Peak, or outside of Albuquerque, New Mexico, observing with a very similar setup. That site is open to the public, and it is also in the path of annularity. So if you have a chance, if you're around New Mexico, you can go down to Albuquerque and see things there.
All right, the annular eclipse is exciting. Again, the total eclipse in April. So we're just so excited about this, and both of them are going to be spectacular to catch. So, again, your research, your work is truly fascinating. What do you enjoy about it?
You know, uh, a lot of people forget that the sun is a star. We live around a star. Those points of light that you see in the sky that you wonder, what's out there in the universe? Well, we're out there in the universe and we live around this amazing astrophysical object that shines light on us and gives life to basically everything on Earth. Of course, it's also a force to be reckoned with, and we need to understand it. I am an astrophysicist. I like to understand the mysteries of the universe. I like to study stars. I like to study powerful physical phenomena in the universe. And the sun is like a laboratory for the universe right in our backyard. It's an amazing way of studying processes that you don't need huge, powerful telescopes looking across many, many light years to study. You can look at it right here in our own solar system. It's not a replacement for looking at the rest of the universe, but what we learn from the sun, we can actually apply to what we learn about things elsewhere in the universe. We can apply it to things we learn about how our Earth works and how the Earth's magnetic field works, how the sun interacts with the Earth, with planets, with satellites and humans in orbit or in space. There's so much to learn about the sun. It's really hard to describe how many different ways. It's fun
Mhm.
and interesting. Um, I guess the if I had to pick one thing, it's really just that I get to study the secrets of the universe with a star right here.
And as we wrap up today, any final thoughts on catching these upcoming eclipses?
You know, if you go and you see the eclipse, I want to stress the fact not only is it an experience that you will remember for the rest of your life, but you are seeing something that very few humans have ever seen with their naked eye. And at the same time, you are doing science. You are looking at the solar corona. You are seeing things in the natural world. You can actually do your own experiments during partial and total solar eclipse. There are all sorts of suggestions on how to do homemade experiments for the sun. If you look those up online, anyone can be a scientist, anyone can do science, but even if all you want to do is bathe in the glory of the solar corona, this is an experience you will remember forever, and you will be in the minority of humans who have ever experienced that kind of event.
Yes, certainly memorable and certainly rare. So, again, you mentioned this earlier. There are many resources and maps online to guide your eclipse experience. We'll leave a link to the NASA Eclipse webpage on the episode 59 webpage. So, again, exciting topic today for many people. As we've said many times, it's a rare opportunity to see the eclipses in our backyard. So, you don't want to miss this experience. Get your approved glasses and make a plan. So, thank you for being here today, Amir, and getting us prepared for these spectacular events.
My pleasure. I really hope that everyone can enjoy this event.
And thank you to our listeners for learning along with us today. You can hear all Technology Today episodes and see photos and complete transcripts at podcast.swri.org. Remember to share our podcast and subscribe on your favorite podcast platform. Want to see what else we're up to? Connect with Southwest Research Institute on Facebook, Instagram, X, formerly Twitter, LinkedIn, and YouTube. Check out the Technology Today magazine at technologytoday.swri.org. And now is a great time to become an SwRI problem solver. Visit our career page at swri.jobs. Ian McKinney and Brian Ortiz are the podcast audio engineers and editors. I am producer and host Lisa Pena. Thanks for listening.